S. You have to find out the time period of oscillations and also the maximum current through each inductor. At t equals 0, the switch S is closed. Find the time period of oscillations of circuit and maximum current through each coil. Okay, right, try to see what will happen. Now the capacitor will discharge through both the coils. The capacitor will discharge through both the coils at any time t. Let charge in the capacitor be Q. Let the current through the coils I1, I2. Then write some equation. Then see what you can do. First get angular frequency of oscillation. Then we'll go for maximum current.
1 plus L2 by CL1 L2 root of
Okay, that one. They're in parallel or series?
parallel.
They'll be in parallel, not in series. Yeah. I'll proceed like this at any time t. After closing switch, the capacitor, say it starts discharging through the both the coils L1, L2. This is C. So let this be plus Q minus Q. The current here, let it be I. Current in this branch, let it be I1. Let it be I2. So this will be plus minus plus minus. I'm treating inductor like a circuit element. Then how these two potential drops? So if you take this point P, AB, like, let me write here. So VAP should be equal to VBP. Take help of the condition. VAP should be equal to VBP. And what is VAP should be equal to? L1 dI1 by dt. This should be equal to L2 dI2 by dt. Let's write. Now dt get cancelled. So therefore this will be L1 dI1, L2 dI2. Integrating this, I'll end up L1I1 equal to L2I2. Then by KCL, by applying KCL here, I should be equal to I1 plus I2. So from here, look at this. Solving equation 192, I'll get expression for I1 in terms of I, then I2 in terms of I. Putting 192, equating 192, I1 plus I2 will be L1 I1 by L2. Similarly, what is the expression for I2? I2 should be equal to, say I'm telling this one, any complicated problem comes, you have to just stick on to potential differences. Are they parallel? Are they series? Applying KCL, then writing loop equation. I think these are the things what we know. There's no other alternative for us. So manage questions like this. So as we go for tomorrow higher level problems, no, I'll just stick on to these things only. We don't have any other method available for us. So these are the expression for currents what we have. Let's write loop equation. Q by C. I'm taking this loop. Plus Q by C minus L L1 di1 by dt. Minus L1 di1 by dt equal to 0. What is Q? Q is the charge. So high is dq by dt, no? I is what? dq by dt.
Minus dq by dt.
Okay, that one. Yeah. I is minus dq by dt. But we have here I1, no? So can I replace I1 in terms of I? Already we have brought this equation. So substituting these equations here. Q by C L1 L2 L1 plus I2 di by dt equal to 0. That we are substituting here. So now I think now we can write it, no? So in place of I, what you can write? dq by dt. So this should be equal to Q by C L1 L2 L1 plus L2 d square I equal to minus dq by dt, this one. So again equating this with SHM condition, d square q by dt square is equal to minus of q by L. LC. What is L? L is L1 L2 by L1 plus L2. Effective what happens? They're in parallel. In exams, you should not solve this much. You know they're parallel. Effective inductance L1 L2 by L1 plus L2, and you have to finish over. You have to wind up. Don't show your hard work there here.
Sir,
Somebody, yeah.
are we not supposed to consider mutual?
If they mention mutual inductance, if they mention, otherwise leave it. Because again, mutual inductance depends upon the coil separated, no? So I'll if I separate them by a distance of say like somewhere around 3, 4, 5 centimeter, or to avoid that mutual inductance, I'll wind up this coil. Means I'll cover this coil so that flux by one will not link it. If they mention, consider it. Otherwise, don't think about that one. So this is the angular frequency of oscillations. This should be equal to finally. Okay, this much is there about the angular frequency of oscillation. Now we have to get that maximum currents across each coil. How to get that maximum currents? We know omega now. Let's take help of this equation. Current I1 will be maximum when I is maximum. That's all, no? Correlate here. The current through the coil 1 will maximum when current across the capacitor is maximum here, because I1 is directly proportional to I. So therefore, what is I max is equal to Q naught omega. What is that I? When I becomes I max, and what is that value should be is equal to Q naught omega. I replace these two inductors by one equivalent inductance that is equal to L. Then definitely according to the LC oscillation circuit, what is I max? I max should be equal to Q naught omega. I'm straight away getting into the concept. I max should be equal to Q naught omega. Q naught is what given for us. Omega is what just now we calculated. I know I max. No. When I becomes I max, I1 will become I1 max. So what is the total equation? This will be I1 max should be equal to L2 I max by L1 plus L2. L2 Q naught omega by L1 plus L2. And what is omega? Omega, we know this much. Let me substitute that. Q naught will be there outside. One L2. This L2 will come inside. So L2 L1C by L1 plus L2. Check it. This will be the maximum current through the first coil. Similarly, for second coil, you can write I2 max equal to Q naught L1 by L2C L1 plus L2. Straight away by comparison only I'm writing it. It will be Q naught L1 L2 L1 plus L2. Finding angular frequency is very easy. So what you should do, straight away check series parallel, get omega. No need to prove that. I think in exams better do practice like this. That's why you'll be on safer side. If they ask you something maximum current, then get involved in the mathematics, writing KCL, KVL, other things. Okay, let me take one more question related to this. Now, what are the possibilities? Again, you check it now. Some 3 times they've asked. In mains, plenty of time they ask. In advance, they ask 3 times. So possibility of asking any of the things, that one.